So let's take a look at a couple of things here. The first thing I wanted to talk about, one of the most foundational changes we can make on any landscape really has to do with water. If we're dealing in situations where you end up with dry periods and you're looking for ways to hold water on the landscape, the system that they've used, kind of terracing, or in permaculture we call it swales, where you actually create an impression, is one of the best and effective methods to do that. Some of you may have seen the video Jeff Lawton put together of a swale and how water moves through the horizon. It's a very effective method for holding water. And very simply, you just dig a ditch on contour. On contour means it's kind of level. And you dig a ditch and you take the soil and you plop it downhill. And what that does is kind of create this reverse effect. So when water comes down the hill, it hits that swale, and because the swale is level, the water doesn't go left, it doesn't go right, it just backs up in there, and it creates this long pocket across the terrain. It's a very simple thing to do, but every time it rains, that will fill up with water, and over a period of 1, 2, 3 days, the water soaks into the ground, slowly but surely, and it takes a long time for that water to move through the soil profile. And all that time, anything that's planted downhill from that water has an opportunity to take advantage of that through its root system. And so in permaculture design, we will plant into that swale system or below the swale in order to capture that water and grow it and turn it into plants. So it's a simple way to dramatically increase production. It doesn't have to be on super sloped land. Here's a neighbor's property of ours. Actually, Wayne was in our last design course, and this was the design project we did for him. He kind of lives on this low spot in our little prairie situation, and whenever it rained quite a bit, his entire yard, it's new construction, and his entire yard would just turn into this bog. And what we wanted to do was to minimize the amount of water moving across his property. So we dug a swale right on the uphill side of his property, and the next night it rained, and we came out the next day, and you can see how it backs up the water, how it holds it and keeps it. Right side is dry, other side is wet. So now he'll plant all kinds of things along that berm, fruit trees and berry bushes and all kinds of things, and they'll take advantage of that water all year round. Here's another landscape up in Wisconsin. This gentleman is a permaculturist, and he planted rows and rows of hazelnuts. And you can kind of see them on contour on the hill there. It's kind of hard to tell. They get quite a bit of rain up there, and rather than dig swales, he wanted to put his plants closer together. But he has access to a sawmill, and he has access to trailer loads of sawdust and wood chips. So he brought that in and laid it all over the place. So mulch acts as a fantastic sponge as well. So you can grow a lot of things on a hillside that you wouldn't necessarily use flat ground for, or what we call agricultural land. You can grow a lot on a hillside with swales. The next slide gives you an example of what's going on there. To the right and to the left, you can see the hazelnut bushes, and these are about 3 to 4 years old. So the first year in the middle, he also, between the rows of hazelnuts, he wanted to have a crop. I mean, why should it just be open? Why should it be grass competing with the crops? And he wanted a crop right away, because when he puts the hazelnuts in, the bushes are very small, right? So he planted this big, thick crop of garlic, and in with the garlic, he also planted raspberries. So over the course of the season, the garlic came in, the raspberries started to come up, the hazelnuts took off, and they became dominant, a little bit taller than everything else. And on year 2, he switched from harvesting garlic into harvesting the raspberries. And by year 4, the hazelnuts had come on, and he started harvesting hazelnuts as well. So it's just a good way of, in a sense, it's called alley cropping, when you have a crop in between the rows of something else. Why just put grass in there, or why till it? Why not grow something useful? What's significant about this design compared to traditional farming is, look at this. On his farm, he's holding water on the landscape. He's sequestering carbon all year round. I mean, as long as anything's turning green, he's sequestering. As soon as spring comes, everything turns green, and he's sequestering carbon. He's building topsoil and fertility every year, and increasing the humus content of the soil. He's not using herbicides, pesticides, artificial fertilizer. He's no poisons. And consider this, especially concerning the hazelnuts. The hazelnuts will continue to produce, and actually the hazelnuts will hit their peak more like around 7 to 10 years. The hazelnut bush hits their peak, and you can cut that hazelnut bush off at the ground, and it will come back, and within 2 to 3 years, you'll have a huge crop of hazelnuts again. He plants one time, and for decades, he has a renewable crop coming in year after year after year, and he doesn't have to replant. No tilling of the soil. A whole lot less work than tilling. And what's significant about these nut crops, hazelnuts and chestnuts in particular, we talk about the chestnut because the new chestnut varieties hold a lot of promise. It's a very sweet nut. And if you look at the carbohydrate and protein profile of hazelnut and chestnut, it's almost identical to that of corn and soybeans. Look at the next slide here. Do you remember George Washington Carver and the work that he did in the 1800s of helping the sharecroppers down in the southern states? Just from peanuts alone, he developed hundreds of recipes, and not just for foods, but for things like dyes and paints, adhesives, plastics. Henry Ford and Thomas Edison were contemporaries of his. And it was, if you look at the next slide, Dr. Carver developed a synthetic rubber from goldenrod. And the Model A, those cars, the tires were made from this goldenrod synthetic material that George Washington Carver discovered for Henry Ford. And it was Henry Ford and Thomas Edison, both of them tried to get George Washington Carver to come and work for them. And, of course, he stayed at Tuskegee University and continued to do his research for the farmers there. All the things that we make from corn and soy, just think of how corn and soy have permeated our culture. Everything from cereals to bread to crackers, all of these foodstuffs, snack foods that we eat, that we depend on those crops, we can make all of those foods from a variety of nuts. And nuts are a perennial crop, right? It's the chestnut that doesn't peak until 30 years. And then if you take care of that tree, it can live for hundreds of years, and you get a crop every year. We can take this kind of annual agriculture and we can turn it into lush, green, and productive perennial agriculture. But we will not do it from the back of a John Deere tractor. We may end up using some tractors. We certainly could probably use the equipment that harvests blueberries. You know, it's a shaking, some kind of cherries and stuff. They have this machine that comes up and shakes the whole bush and all the berries fall off. They're experimenting with a shaker to harvest hazelnuts that way. So certainly we can come up with some kinds of automation. But if we're looking at trying to find perennial crops, we're trying to find ways to hold our topsoil and to grow foodstuffs, we can certainly find ways to do it with nuts and different types of grains, certainly beans and peanuts and things like that. And how much food can we grow? Can we ever meet the mass production that industrial agriculture has done? Well, look at this, biointensive and biodynamic farming gardening methods. Most of you are familiar with these, I'm sure. But they've done research to find out if they really took a certain square footage, you know, a half an acre, and they gave it everything they could and really took care of it and planted rotational cropping, you know, sequential cropping where you plant things closely and you every time you harvest something, you plant something else. How much food can we get? And in some of these test systems, they actually produce 10 times the amount of food that industrial agriculture can produce. All right? Can we feed the world? Yes. And we don't need all these flat, arable acres either. We can grow food on hillsides using permaculture methods as well. And we can even grow food in very dry areas using permaculture methods. So land that is not considered arable now could actually be turned into food production. It just takes design and desire.